So I'm here at the Total Environment Simulator at the Deep, which is the University of Hull facility, getting very wet. So here is an experiment looking at how landscapes evolve under different types of rainfall. We're using, so these little hoses are putting water onto the landscape and moving all that sand around. This is part of a Hydralab project, Hydralab Access project, which allows researchers from around Europe to use this. So I've come here where it's a bit drier. They've just finished one of their experiments now, where the rain has been turned off, and now they're recording the measurements taken by each of the little rain gauges across the catchment. So I was hoping to speak to one of the Hydralab people here, so either Hannah and Vitsa, but neither of them will come on camera and talk to me, so I'll be telling you what's going on here. So basically this is the calibration stage of the experiment. They're running the rainfall with different intensities and recording what's in each of these rain gauges to make sure that they understand the spatial pattern of the rainfall. It should be uniform, but obviously the hoses are there's going to be some sort of uncertainty and error around the amount of rainfall, the amount of water that's coming out of those pipes. So this is just testing for that and seeing what the spatial patterns are. This will go on for a few weeks before they move on to the final experiment. Okay, so we're back in the flume and we've now got the highest intensity rainfall on. It's very wet in here, so Hannah, who's just out of shot, you might be able to see sort of half her face squished up between the two cameras and the Gear 360, is kindly holding an umbrella for us. So I'm here with one of the researchers, so do you want to just introduce yourself and tell us what's going on?
Sure, hi there, my name is Jantine Baartman from Wageningen University. We're doing here a project in this big laboratory in Hull. And what we're going to do is we want to do different sequences of rainfall events. So this is the highest intensity one, but we also have a medium one and a low intensity one. And then we want to vary these intensities in a sequence. And that will have, for instance, 500 millimeters of rain in total. And that what we're going to do is different sequences with different rainfall events. So we'd have the low one first and then the high one, and in the next sequence you would have a high one, a medium one. But in total they'll have the same amount of rainfall. Okay. And we'll see what that does with erosion, because that's what we're going to measure here as well.
Okay, and so you're basically trying to show how the rainfall will different rainfall affects the landscape changes there.
Yeah.
Brilliant.
Yeah.
Thank you very much.
Let's see what we get.
So I'm back in my office now, back in the dry. My hair's nearly dry. It's horrific weather outside still. It's even wetter than at the Deep. But I had a great time with the Total Environment Simulator, seeing the excellent research that is going on down there. I just wanted to finish off by just putting that into context. So one of the things we saw while we were down there were these rain gauges that they put on the riverbed. Some of these were falling over during those tests because the artificial rivers that were forming in the sand were undermining where these rain gauges were standing and knocking them over. Now in real life, that rain gauge could be an electrical pylon, or it could be a bridge, or it could be a building. And rivers do move over time, a lot slower than they do in the flume, but they do move, and they can put our infrastructure at risk. So when we're building computer models to forecast things like flooding, we also need to account for changes to the rivers and how they move and put these things at risk. When we build these computer models, these are based on the physics that we get from these flumes. So the understanding of the experiments like they're doing down there then drives our computer models, which then drives our predictions and tells us which areas are going to be at risk. So that's why this is really important.